everyone. This is Miss Frankovic, and
Hi, Miss Thomas.
we're here to talk to you today about dimensional analysis. It's kind of the complicated word or term that we use for conversions. So today we're specifically looking at metric conversions. And what we're talking about with conversions is a method of changing from a given quantity in a known unit of measurement to an entirely different unit. All right. Now the important thing here is that when we're converting, that value does not change, right? So we're not changing any kind of value. We are only changing the unit, all right? So our conversions keep the same value. We're just going from one unit to a different unit. The method for doing this is we're going to start with one value in a given unit. So whatever our given unit is, we'll multiply by a conversion factor, and we get the same value in our wanted unit. So in a different unit of measurement. Same value, different unit.
So, you guys already are going to be able to figure out what our value in our given unit is, and you're going to solve for our value in our wanted unit. But in order to do that, you have to first figure out what the conversion factor is. So, a conversion factor is a fraction or a ratio whose numerator and denominator equal the same quantity expressed in different units. Both of these units are always going to be told in the question, or they're going to present themselves in the question. I know this seems confusing, but you guys already know how to do this. For example, eggs. You already know there are 12 eggs in every 1 dozen. That ratio represents that relationship right there. That's a conversion factor. It can also be expressed in upside down. So 1 dozen eggs, or 1 dozen is equal to 12 eggs.
All right, and you know that these are the same, right? So when we're looking at our conversion factors, these two are equal to each other. So every conversion factor is actually just equal to 1, which is why when we take our value and multiply it by 1, we get the same exact value in the end. All right, so we're going to walk through some problem-solving steps for metric conversions. And we've kind of laid this out as a mnemonic to help you remember how to convert from one unit to another and what the equivalencies are between two different units. All right, so our mnemonic here is King Henry died by drinking chocolate milk. The K here stands for kilo, H is hecto, our capital D is deca. Here's our base, all right? Now our base is any of our base units without a prefix on it, right? So meter, liter, or gram. Those are our base units. We have deci, centi, and milli. A couple things to notice with how this is set up. Kilo is the largest unit, which is why it's at the top of the stairs. Milli is our smallest unit, which is why it's at the very bottom, all right? Base is obviously right in the middle of our mnemonic here. When you're looking at this, we can see our equivalency statement from the values that we give here. 1,000 over 1, 100 over 1, 10, 1, 1 over 10, 1 over 100, 1 over 1,000. You can see that each step is changing by a factor of 10. All right? So the way we have it set up here is a fraction. Whatever's on top, so right here it's 1,000 over 1, whatever's on top is our base. Whatever's on bottom is the prefix. So we read it as 1,000 meters in a kilometer. Down here, for example, where the fraction is upside down, we have 1 over 100. The base is still on top, the prefix is still on bottom. So here, we actually have 1 meter base is equal to 100 centimeters, the prefix.
Okay. So, this King Henry died by drinking chocolate milk is going to help you figure out your equivalency statements and conversion factors that we're going to be used to solving this next problem, which is to convert 1.5 liters into milliliters. Now, every time we do this, every time we do dimensional analysis, we have these problem-solving steps that are going to help you to solve all of our problems, okay? The very first step is to write the equivalency statement that you are going to use to solve the problem. Ms. Frankovic is going to do that right now.
So see, the problem uses liters and milliliters. The equivalency statement will be a ratio between our liters and our milliliters. So if we look at liters, that's our base, right? Milliliters is right here. So we see that our fraction here is 1 base over over 1,000 prefix, which is milliliters. We could also write this as the reciprocal, 1,000 milliliters over 1 liter, right? So we can use that. These are just our equivalency statements.
Great. Step 2 is to make a skeleton. So within the skeleton, you want to write your given in the very top left, including your unit. So you write the value and the unit. Step 3 is to place our given unit on the bottom so that we cancel out.
Liters is given, so liters is going on the bottom.
And our wanted unit on top, which is step 4.
We're trying to get into milliliters, so milliliters is going on top.
Next, you fill in your numbers from your equivalency statement or your conversion factor in order, right there.
So this is going to be our conversion factor, this entire thing right here. We can look over it here and see where's milliliters on top and liters on bottom. 1,000 milliliters is equal to 1 liter.
Now you're done with all the setup and all you have to do is plug and chug.
Right? So
all you do is you multiply across the top and then divide by the bottom. So we're going to multiply 1.5 times 1,000 and then divide that by 1.
We're going to get 1,500 milliliters. Liters crosses out because it's on top and bottom. Anytime you have a unit that's on top and bottom, it will cross out.
Okay, so we expressed it with our correct units and our correct number of sig figs, which is 2.
We have 2 sig figs here. We have 2 sig figs in our answer.
Both of those zeros aren't significant, and then we want to make sure that we always box our final answer.
All right. Last example that we have is if we are doing multiple step conversions. Right? So when we're doing multiple step conversions, what that means is that the base unit is not going to be part of the conversion. All right? So we'll see that we're going from one prefix to another. That base unit, meter, liter, or gram, is not part of the question. It's not the wanted and it's not the given. We still need to convert to the base unit first. All right? That's the important part here. To make this easier and to use our mnemonic that we showed you, it's a lot easier if you convert to the base unit first.
Okay. So, because we don't have our King Henry died by drinking chocolate milk over here, we went ahead and gave you the 2 equivalency statements that you have to use for this example. So, if we are converting 55,000 centimeters to kilometers, we want to go ahead and make sure that we have our meters to centimeters first, or our centimeters to meters written out first, because we want to first convert to our base unit of meters before we go up all the way to our kilometers, up the staircase. So there's 100 centimeters in every 1 meter, and then there are also 1,000 meters in every 1 kilometer. So that would be our second equivalency statement. So if we wrote this out for you, you would definitely see that the first step would be to make our skeleton, and then to plug in centimeters on bottom, meters on top, and then go ahead and plug in our values for that. And then you're going to just continue to make your skeleton over here and put your meters on the bottom and our kilometers on top. So our final unit that we are always trying to get to is going to end up right here as our very last top unit. Okay. So then you're going to go all the way, and all you do is you multiply across the top and divide by the bottom. Okay? So I'm going to multiply 55,000 times 1 times 1. And I'm going to move the decimal. Is that okay? Okay. 55,000 times 1 times 1. And then I have 100 times 1,000. And I'm going to move it 5 decimal places.
1 for each 0 you see. So there's 5 zeros. You move the decimal 5 places.
Okay. So if my decimal's here, I'm going to go 1, 2, 3, 4, 5. Okay. And I have kilometers. Now, I can't write my final answer like this because I have, first of all, too many significant figures, and I need a 0 in the front. So first I'm going to write my 0 in the front to show, like, yes, this is a decimal place. And then I am going to go ahead and count my significant figures in my original problem, which is 1, 2. These 3 zeros are not significant. Oops. So my final answer is going to be 0.55 kilometers, which I will put a box around.
That's it.
Hi, Wally. Hi, Wally. Hi, Wally. Hi, Wally. Hi, Wally. Hi, Wally. Hi, Wally.
Oh, yeah. Oh, what now? What now? What now? What now? What now? Why are you attacking me?
Look at how.
She was like, I've joined the party. I've joined the party.
Oh, that's really funny.